Understanding AI ethics can be complicated because you have to understand something about AI, and you have to understand something about ethics, and then of course you have to understand what does the intersection of those two fields look like. So this leads to a lot of confusion and people not really sure where they should dig in, where they should do research, where their interests really lie, if they've got certain job-related responsibilities, exactly how to wrap their heads around it so they can discharge those responsibilities well. So this is my attempt to articulate the AI ethics landscape. I deliver this in sort of a lecture format. It's a 23-minute talk just by me and only me, unfortunately for you. And at the end of it, you should have in your head a picture of the AI ethics landscape, a deeper understanding of what the sources of the ethical risks of AI are, and what organizations can do about those risks. Okay, that's what this episode is about. Pretty straightforward. If you are one of the many people who are listening to this podcast on a mobile browser, then please go to Apple or Spotify or one of those platforms and subscribe. If you like this, especially this episode actually, then you should buy my book, which is also called Ethical Machines. That book also lays out very clearly, at least as clearly as I can manage, what the AI ethics landscape looks like and how to understand the risks and what to do about them. So that's Ethical Machines. And then there is my Substack, readblackman.substack.com. But I think that by the time you finish listening to this episode, plus the book, you're sick of me. No need to go to my Substack. And finally, you can email me to tell me how sick of me you are at em@readblackman.com. All right, thanks. Let's go listen to more me. I want us to understand and internalize the AI ethics landscape. So that's what we're going to talk about today. The first distinction that matters when we're talking about AI ethics is the distinction between AI for good on the one hand and AI for not bad on the other. The AI for good people have ethical goals, explicitly ethical goals. And if you don't like ethical goals, they want to pursue, for instance, the United Nations Sustainability Development Goals, the SDGs. And the AI for good people ask, how do we pursue those explicitly ethical goals using the powerful tool that is AI? So they've got noble goals, they want to use AI to do it. How do we use the powerful tool that is AI to pursue those ethical goals? AI for good. AI for not bad is asking a different kind of question. The AI for not bad people, and I'm really one of them, it's sort of where I live. AI for not bad says, we're going to do what we're going to do. We've got our sort of ordinary business objectives. How do we pursue those ordinary business objectives using the powerful tool that is AI without incurring ethical, reputational, regulatory, and legal risks? Because there's all sorts of ways that things can go sideways. So how do we make sure that in using our tool to pursue our business goals, we don't make things go ethically sideways? That's AI for not bad. I call it AI ethical risk management. Some people call it responsible AI. Some people call it AI governance. Some people call it trustworthy or trusted AI. It doesn't really matter. The main thing here is we're trying to pursue our regular business objectives, making sure that AI doesn't go sideways. That's the first important distinction. One reason why I think it's so important, by the way, is some people think when they hear AI ethics, we're all sort of going to hold hands and sing hallelujah together. And this is sort of pie-in-the-sky stuff, not appropriate for businesses. And in some cases, honestly, that is what people are talking about. But that's really the AI for good folks. So when we see that we're talking about AI for not bad, now we see why this is business relevant. It's ethical, reputational, regulatory, and legal risk management. And for what it's worth, I think that AI for not bad is not only speaking to business priorities, it's also speaking to ethical priorities. Because business priority is pursue your business objectives, get the ROI that you need on those without things going sideways. And ethical, if there is an ethical principle number one, it's first do no harm. So I think this is one place where having a deep concern for the ethics of AI and having a deep concern for pursuing ROI actually coincide. AI for not bad. Once we understand that we're talking about AI for not bad, there's another distinction that I make. It's one between what I call content on the one hand and structure on the other. When we're talking about content, we're asking, what are the ethical risks of AI and what are their sources? When we're talking about the structure side of the house, so to speak, we're asking the question, and what do we do about it? How do we actually go about identifying and mitigating those risks? That's the structure side. Mostly, for the most part, people see scary headlines about AI, privacy violations, hallucinating large language models, and they run over to the structure side and they say, what do we do? What do we do about this? And that's too fast. It's a mistake. And the reason it's a mistake is simply that if you only understand the risks at that headline level, then you're not going to devise the right solution for how to deal with them. You've got to go deeper on the content side if you're going to develop the appropriate structure for dealing with those things. So in this session, I'm going to talk a little bit more, not tremendous detail, but some detail about what the nature of the risks are. What are those ethical risks of AI, and what are their sources? Before proceeding, I want to say something about what AI is, because there's lots and lots of talk about AI. There's very technical definitions of AI, and we're not going to use any technical definitions. Here's how I think about what AI is. AI is software that learns by example. And that's all it really is. It's super simple. Yes, the math, the coding, all phenomenally complex. But at the conceptual level, it's totally simple. It's software that learns by example. And we all know what software is, right? You're probably using it right now as you watch this video. Your email is software. Any website you go to is software. The apps on your phone are software. We're very familiar with software, obviously. And we all know what it is to learn by example. You can, give kids pictures of pigs and they understand what a pig looks like, so that when they see a pig in a photo of a farm, they can say, oh, that's a pig. You can see, to sort of make it a little more highfalutin, you can give a bunch of examples. I can show you a bunch of examples of Impressionist paintings, and then you'll be able to pick out the Impressionist paintings in a museum. So we know what it is to learn by example, we know what software is, and it turns out that AI really is that simple. It's software that learns by example. So let me give you an example of such a thing. If you want your AI to learn, let's say what your dog Pepe looks like in photos, you're going to give it a bunch of examples of Pepe in photos, and it's going to learn from those what Pepe looks like in photos. So when you take a new picture of Pepe, it sort of sees Pepe in that photo and puts it into the Pepe folder. No big deal. Software that learns by example. Here's the thing though. Once you understand that AI is software that learns by example, you can understand all sorts of ways about how things can go wrong. First, let's say non-ethics issues, just from a straight up accuracy issue. Suppose you only gave your AI pictures of Pepe sleeping, and so lying down, and it's dark, right? That's all you gave. That would mean that your AI would be really good at recognizing Pepe when Pepe's eyes are closed and he's lying down and it's dark outside. If you gave it a photo, you took a new photo of Pepe running around eyes open outside during the day, it hasn't seen an example like that, so it's going to get it wrong. So what does this mean? If you want your AI to be accurate, then what you're going to do is you're going to give it lots of different examples of Pepe. You'll show Pepe lying down, you'll show Pepe standing up, running, jumping, whatever it is. Eyes closed, eyes open, different lighting conditions, different angles, so on and so forth. So to get your AI to sort of be highly functional, you want to give it lots of examples. I'm talking now about an example of what's called narrow AI. This is just an AI that is good at a specific task. This is, let's say, pet photo recognition software. There's, of course, other kinds of AI. You're all familiar with generative AI. You're all familiar with things like a ChatGPT, where you write to the AI and it responds back. That also is just AI that learns by example. It gave it examples of words being put together in a way that makes sense. How did it do that? They give it books and magazine articles and websites and all the text they can find, because all that text is examples of words being put together or cobbled together coherently. So what you have then is an AI that knows how to put words together in a coherent fashion because it's seen thousands, tens of thousands, billions of examples of words being strung together coherently. So even if you're talking about generative AI, you're still talking about software that learns by example. Now, not only do we get a grip on AI works well when you give it lots of different examples, right? If we had only given a large language model like a ChatGPT examples of people talking about their pets, it'd be really good at talking about pets, but about nothing else. This is all we need to understand where the ethical risks of AI come from. I won't talk about every single one of them, but I'll talk about a bunch. So let's start with a pretty simple one, explainability, what's called the black box problem. It's a debate about how big of a problem this is, but you should know what the black box problem is. When that photo recognition software looks at all those examples, all those photos of your dog Pepe, it doesn't see what we see. We see 2 eyes, 2 ears, a nose, so on and so forth. The AI sees thousands of pixels and the thousands of mathematical relations among those pixels. And it sees this giant mathematical formula that relates all those pixels to each other. Let's just say it's a 50-page mathematical formula, something along those lines. You and I can't hold that in our heads, right? You can't, I can't put a 50-page mathematical formula in our heads. So when it says, yes, that's Pepe, or no, it's not Pepe, we can't understand the formula that made it say yes or no. So why did it say, yes, that's Pepe? Why did it say, no, it's not Pepe? Because of this mathematical formula, but we can't keep it in our head, so we don't really understand. That's the black box problem. This is an example of unexplainable AI. We can't explain how it arrives at its conclusions. Now, that's not a big deal if you're talking about photo recognition software for pets, no big deal. But if you're talking about, let's say, an AI that says yes or no to giving this person an interview based on their resume, or admitting them to a university or not based on their CV, their resume for college. If it's for a mortgage application or some other kind of loan and the AI says yes or no, and we don't know why the person was approved or denied, that's a big deal. So why does explainability matter? For some people, it matters because if it's not explainable, that means we don't know how the machine works. And if we don't know how it works, then we can't trust it. By the way, generative AI, the large language models that you talk to, black boxes, totally black boxes. We don't understand why it comes up with the outputs that it does. Again, there's some complexity there, but nobody thinks that we really understand why we get the outputs that we do. That's black box AI. Remember, it's software that learns by example. By the way, I should say one other thing, which is you can swap out the word example with the word data. Now you sound fancy. AI is software that learns by data. Doesn't learn by, fancy word for example is just data. So how do we train the AIs? We give it lots of data and it learns from that data how to spot Pepe in a photo, what a good mortgage application looks like, how to string words together coherently so that we get these useful outputs. So in all these cases, we're just talking about software that learns by data. And incidentally, one reason why I think it's really important to sort of speak in this language of software that learns by example is that it's a way of stopping technologists from talking to us in a way that we can't understand. But we need to understand these issues if we're going to engage with the data scientists and engineers appropriately so that we can do the AI ethics work that we need to do. Let's turn to privacy violations in AI. So where do those come from? Well, remember, AI is software that learns by example. A fancy word for example is data. And oftentimes that data is about people. It's about you, it's about me. Which means that the fuel of AI is data, often data about people. And what do data scientists want? They want their AI to go as far as possible. If you want your AI to go as far as possible, you need lots of fuel. So it's the nature of AI, that it requires more and more data. The more data you have, all else equal, the better your AI is going to be. What does that mean? It means that data scientists are incentivized to collect as much data as they can. But it can be the case that the collection, the storage, and the use of that data can itself constitute a violation of people's privacy because they shouldn't have a right to that data. They don't have a right to that data. So it's built into AI because its fuel is data, often data about people, that it implicitly incentivizes people to get whatever data that they can. So that's one reason why we have privacy risks when it comes to AI. There's more to say there again, but this is just a crash course, so I'll leave it there. But you can already see, since it's software that learns by example, software that learns by data, we get privacy violations. Let's turn to perhaps one of the biggest ethical risks in AI, the problem of biased or discriminatory AI. We can go back to Pepe the dog example. Suppose I give my AI software lots of examples of Pepe, but I don't give examples of Pepe outside, when it's light outside, running, etc. It's not going to be able to accurately label those photos as photos of Pepe. Now, suppose, as has happened, I create photo recognition software of people, and I give it lots and lots and lots of examples of photos of people. But what if I give it tons of photos of, say, white men and very few photos of black women? What's going to happen? You know what's going to happen. You're going to have an AI system that's really good at recognizing white men and really bad at recognizing black women. Again, it's because we didn't give it enough examples of, let's say, black women in various lighting conditions, photos taken from different angles, for it to be good at recognizing black women in photos. So that's a case of biased or discriminatory AI. There's similar kinds of issues as well. If you train your AI to read resumes and give it a score for, yeah, you should interview this person, or no, you shouldn't interview that person. And those resumes that it learns from, the examples that it learns from, are the examples from the past 10 years and decisions that hiring managers have made about whether to give that person an interview or not. It has turned out in a real life case, that what it learns is, oh, we don't hire women around here. And then what it does with all those new resumes it gets is it red lights the women's resumes and it green lights the men's resumes, all else being equal. So again, if one way of getting biased or discriminatory AI is you have examples that implicitly embed or reflect certain kinds of, let's say, historical social biases. One thing that I want you to notice here is that the bias in an AI is not the result of the biased intentions of the data scientists or engineers who are building the AI. It's not that we're dealing with bad behavior here. What we're dealing with is bias that is embedded in or is reflected in the data that they use. They can't always see that the bias, as it were, is in the data because we're talking about thousands, tens of thousands, millions of data points. And then they wind up creating biased AI unintentionally. And there's different ways of trying to mitigate those biases, and they can try those strategies and tactics to mitigate the biases, but there's always going to be varying levels of success. But notice the problem of bias in AI, again, is not the bad behavior of data scientists. It's the nature of the beast, the nature of AI, that it needs lots of examples, lots of data, and that data may, despite the intentions of the developers, reflect certain kinds of societal or historical biases. So again, you get bias in AI because AI is software that learns by example, and those examples can be screwed up in a variety of ways. Okay, let's turn to a pretty fun one, hallucinations. Hallucinations are interesting. So hallucinations are when large language models like a ChatGPT or an Anthropic or a Gemini, when it outputs false information, it just says things that are totally untrue. Now, why does that happen? Because remember what large language models are doing. Remember how AI works. It's software that learns by example. What did they do? They trained the LLMs by showing words cobbled together coherently. They just have to make sense. They don't have to be true though, right? It's just a matter of pushing words together in a way that makes sense, that's intelligible, that's coherent. But if I say, the earth is flat, that's coherent. The meaning of the sentence is clear. Right? I put the words together well. It doesn't reflect reality because the earth isn't flat, but nonetheless, it's a meaningful, coherent sentence, even if it's false. So when a ChatGPT or a Gemini or a Claude, when they put words together, they're just putting words together in a way that makes, if you like, semantic sense, is intelligible. It's not doing it with an eye towards what the truth is. So once again, since it learns by example, what the examples that it learned from are just words put together coherently. We get coherent outputs, coherent sentences and paragraphs from our large language models. But what we don't get is truth, not every time. And that's the hallucination problem. I'm going to talk about one last issue. People think that they can trust the AI's explanation for why it gave you the recommendation that it did. So we're talking about LLMs in particular. So you ask your large language model, your ChatGPT or whatever, you ask it for advice, and it gives you some advice, and you say, oh, well, why did you give me that piece of advice? And it says, oh, well, I gave you that piece of advice because of blah, 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 blah. But that blah, 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 blah is totally made up. It's not the actual explanation for why it gave you that advice. Because here's the thing, remember, it just puts words together in a way that makes sense. It's not a reasoning machine. It doesn't weigh evidence. It doesn't engage in deliberation. What it does is it makes you think that it's reasoning when it's really not, which, to be clear, can still provide some amazing uses. It doesn't reason, but it does something that creates outputs that are similar to the result of reasoning, but it's not actually reasoning. The problem here is that when we go ahead and ask the AI, why did you give me that advice? And it tells you why, it's actually just making that up. That's actually just another hallucination because it doesn't give you advice based on reasons. It's not that kind of machine. Now, why is this such a problem? The reason it's such a problem is that we have what's called automation bias. Automation bias is when people defer to the outputs of an AI. You just trust it because a computer said it. How can the computer get it wrong? And this happens more often than you would think. There are famous or infamous cases of people driving into lakes because Google Maps told them to. Google Maps says, take a left. They see there's a lake there, but they take the left anyway because the computer said so. So that's a case of automation bias. We defer to the machine, because we think machines can't get things wrong. So you take that with a large language model, right? Someone's working with a large language model. It tells you to do this or recommends that. And you say, yeah, okay, but why? And then it gives you a reason, blah, 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 blah. But number one, because you're probably suffering from automation bias, just like we all are, you're inclined to believe the machine. And then when the machine gives you what sure looks like an explanation for why it gave you that advice, you're going to be even more inclined to defer to the AI. So what we have here is a risk of being overly deferential to AI because of automation bias and because it purports to give us explanations for why it gives us the advice that it does, when in fact those are not the actual explanations for why it gave us that advice. We now should have in our heads that AI is software that learns by example, and because it's software that learns by example, we run into issues with hallucinations, with bias, with privacy violations, and more. We also get use case specific ethical risks. So this is less about the fact that AI is software that learns by example, and more about we're using AI to do a certain thing that raises certain kinds of ethical problems. I'll give you a very obvious case, self-driving cars. It's not built into AI that you've got to use it to create a self-driving car, but you can do it. So you put it to the purposes of making a self-driving car, and now you have this new ethical risk on your hand, specifically maiming and killing pedestrians. So bias, explainability, hallucinations, that stuff is built into the AI. That's, if you like, the nature of the beast of AI that it gives rise to these problems. And notice it's not the mere possibility of those risks being realized, it's the probability of those risks being realized. They all have been, they all have happened, they've all been realized. The others are not the nature of the beast, it's the purposes to which you put the beast, like making a self-driving car. So when you're thinking about what are the ethical risks of AI, the content side, you should both be thinking about what are the kinds of risks that are inherent into the kind of thing that AI is, software that learns by example, and what are the kinds of ethical risks that arise by virtue of the purposes to which we put the beast. That's all I'm going to say about the content side. Like I said, there's way more detail to go into on all of those things. I didn't talk about the environment, there's environmental costs of using AI. We're going to put that to the side for now, do more advanced things another time. Now I want to say a little bit about the structure side. So remember, we're talking about AI for not bad. AI for not bad is divided between content and structure. Content asks the question, what are the ethical risks of AI and what are their sources? The structure side asks, and what do we do about it? There's an important distinction to make here now on the structure side. When people think about what should we do about the risks of AI, how do we manage, identify, mitigate those risks? There's a question about how do we do it at the model level? This particular AI solution, we built this AI solution. How do we make sure this thing's not ethically messed up? That's the model level. And then we have the enterprise-wide level. So this is, let's just say you're a Fortune 500 company or just a large organization. AI is coming in through all the cracks. It's coming in through HR. It's being built in-house. It's being procured from third parties, so on and so forth. The question then is, how do we manage the risks of AI across the entire enterprise? Now, when we talk about the risks at the model level, we're going to be talking about what are the responsibilities of the builders of that AI, what are the responsibilities of the people using the AI, what kinds of technical tools can we use to, say, track biases or privacy violations of that AI. That's the model level. At the enterprise level, we're going to be talking about things like what's the appropriate enterprise-wide procedures, what should the policy look like, what does the governance structure look like, do we have an AI risk board and an AI ethical risk board, and who serves on it, and what's the authority of that board? Do we have metrics for tracking whether we are actually doing what we said we're going to do when we said we're going to develop AI in a safe way? So when you think about the structure side, don't just think about how do we keep this particular AI safe. We've got AI across the board. We're dealing with tens, hundreds, thousands of AI models. How do we systematically and comprehensively identify and mitigate those risks of AI across the enterprise? That's creating an AI ethical risk program or responsible AI program that's being engaged in AI governance. So again, I'm not going to even go into detail there, but what you should understand is that you got this content stuff. These are the sources of the ethical risks. And then there are two levels on the structure side by which we deal with it. There's that model level, team level, very specific, how do we manage the risks of this AI? And then there's the enterprise-wide challenge, how do we create an AI ethical risk program that systematically and comprehensively identifies and mitigates those risks? Okay, if you understand all that, you understand a lot about the AI ethics landscape. Yes, not everything, of course, but 90% of that landscape. And the rest of your mission, if you like, if you wanted to go deeper, is to go deeper on each one of those things. How do we get more specific about those sources of risk? How do we get more specific about the strategies for mitigation of those risks? How do we get specific about what should a policy look like? What should our values be? What should our training program look like to make sure that our employees know what to do or how to spot ethical risks or how to smell ethical risk smoke and then know what alarm to pull? If you can think about, if you have all that in your head now you know where you need to dive into more detail, given what your interests and responsibilities are.
Thanks so much, everyone, for listening. And now let me thank the people who have made this podcast possible. So, first of all, we have Delano Alexander. He's been with me since day one. He showed me even how to start recording a podcast in the first place. He does editing stuff. He's been fantastic, and he does really everything I ask him to and more. I've never met anyone else who just says so much. Yeah, I don't know how to do that, but I'll figure it out. What more could you ask for in a producer? Next up, Jennifer Strong, my podcast guru. I don't know what else to call her. She just has advised me on how to design the podcast, how to grow it, and she's responsible for, if you like, this kind of season 2 relaunch and everything around it. So thank you to you, Jennifer. Next up, Meg Marco, responsible for all the excellent artwork. Before I did the artwork, I didn't really know what I was doing. We put it together. It worked well enough, but I think Meg really did a phenomenal job bringing everything together. Garrett Lang, sound engineer that I frankly don't deserve. He's just too good for this podcast. Don't tell him I said that, though. Next up, Benjamin Koltgen. He is a professor of philosophy who has helped me source guests, identify who's interesting, who has things to say, etc., etc. So without him, I wouldn't have anyone to talk to. And then finally, Ashley Wasylenko, who helps with all manner of administrative things, making sure that the podcast guests find their way to the podcast, can schedule the recording, get their bios and headshots, and really just keeping the show on the rails and me organized. Thanks to all of you. Really appreciate all your hard work.